Alright, our video on the association. Right? So here's a scatter plot that shows the relationship between the number of fouls and the number of points scored by NBA players in a recent season, right? So each point, right, if I consider this point, this particular player committed somewhere around 325 or so fouls, right? Somewhere in here, maybe close to 350. That player committed around 350, 325 fouls, and they scored around 1,000 to 1,200 points, right? Maybe closer to 1,200, right? So this is a player, and here are all the players for a recent season. So let's describe the association. Let's go back. Do we remember what we're supposed to say? So what we might say is that some might look at this and look at the things and say, hey, I might be able to come in here and kind of look to make a line that maybe cuts through all my things and is pretty close, right? And some might say, hey, I have a moderate, positive, linear relationship between my fouls committed and the point score, though the variability increases as fouls and points increase, right? That I kind of look at this piece that the variability is increasing over here, okay? And others would say, hey, really, I don't know that that's linear, right? It seems a little more non-linear to me, right? So they might say, hey, I have a strong positive curved relationship, right? That I seem to have, right, maybe some curved setup that better models this data, right? Or you could say a strong positive non-linear piece, okay? And that could be correct. Now, which one would be more appropriate? Well, without knowing the residual plot and being able to say, hey, here is my least squares regression line, here is my correlation coefficient, here is my residual plot, without looking at that and seeing, is there a pattern in the residuals? And if there is, linear is no good. I really can't tell that one is better than the other necessarily, though I would probably go with strong positive curved based on this increasing variability. Because think about it. If I get a line through here, what's happening to my residuals as the fouls increase? My residuals as the fouls increase because of this increased variability is getting larger and larger, right? Well, if that's happening, my residual plot, let's just kind of think of what my residual plot might look like, right? I might be pretty close in, but then as those fouls increase, my residual plot is increasing up and down. And so it's kind of tight in close, but then it gets worse, wider up high, and we say, yeah, it's probably not going to be moderate, positive, and linear. Right? The increased variability, we're probably going to need to say it's strong, positive, and curved. But there will be some situations where it's hard to distinguish, and you'll look at the residual plot, and you'll look at your R value, and 6 people would say, it's this, and the other half dozen would say it's that. Okay? So, always, though, talk about strength, direction, linear or nonlinear. And you can talk about curved if you see this curved piece. Okay? So, should NBA players commit more fouls if they want to score more points? Explain your answer, right? I want to see what y'all come up with for this. What would you say, right? What's the idea that's being asked here? Right? And C, what may you wish to consider to determine if a linear model is appropriate for this data? You want to consider that residual plot to look for the randomness of the residuals. Alright, I want to make sure that I have no pattern in my residuals. If I do, a linear relationship is not appropriate. Alright, and then finally, when does association imply causation? Right? Never with observations. Only with good experiments, with randomized treatments, and control for confounding variables. Right? That if I'm doing an observation, I am never going to have association or correlation imply causation. Never, if it's observations. But if I have a good experiment with randomized treatments, control for confounding, replication, right? I need to be able to have my replication in here with my experiments as well. Right? I need to be able to have my comparisons. Right? Randomized treatments, control, comparisons, replication. If I have all of that, then cause and effect can be stated. Okay? Otherwise, observations, like in this would be observation. Nope. Cannot say that fouls lead to points, or that points lead to fouls. Might just be a relationship there, but not a cause and effect.